So let's get into that today. This is going to be 4.2b. Riemann sums, more kinds of Riemann sums. So what other kinds of Riemann sums can we have? Well, so far we've had, remember, a Riemann sum is finding the area under a curve, right? Here's a curve, you go from point A to point B, and you slice your curve either the left side or the right side. You slice it into rectangles, right? Using either the left edge or the right edge of the curves here, of the edges, right? Slice a function into rectangles and find the area. Find the area. That's what a Riemann sum does, right? So there are actually 4 kinds. There's 4 types of Riemann sums. We've covered 2 of them. We've covered the left side, left side, called left end, left side, where we use the left side of the height, right? We've called the right edge, right side Riemann sum, where we use the right side of the edge to do the triangle, to do the rectangle. Another kind is the midpoint. What other kinds are there? Well, then another type we could use, midpoint sum, where if you have a function, right, and you slice it here, and you slice it, hold on, let me do this better. If you have a curve, right, and you slice it here, and you slice it here, instead of using the left or the right side, you imagine a kind of middle point. You find the midpoint, and you use that as the height. It's kind of a halfway between, right? Instead of using the left edge or the right edge, where you're kind of, missing more chunks of the curve, right? Yes, go welcome. Where you're missing more chunks of the curve, right? With the left side, you use the height here. With the right side, you're using, oh goodness, using the height over here. With the midpoint one, you're using the middle point, halfway between the 2 edges. So you have an edge, right? But you don't use either edge as the height. You use the middle as the height. You use the kind of halfway average between. So let's say this is a 5 and this is a 7. You would use the value of 6. If this was x was 5 and here this edge was 7, you would use 6 halfway between as your height value, as the f, as the thing you plug into the function to find the height. So use, let me do this in red. Use the value, use the x value halfway between the edges, for the height f of x. So for the midpoint rule, you're using the height halfway between your two edges. It's kind of a weird way to use it, but it's a good like average, right? It kind of is another way you can think of finding like an average, I guess, of a Riemann sum. It's a better, right? You miss a little bit on this side, you gain a little bit on this side, and hopefully overall it balances out. So midpoint method is one more method. And the last method, this is new here, we're going to talk about that today. And the other way is, instead of using the left or the right, let's use both. And instead of a straight line, what if we made an angle? Well, that shape would be a trapezoid. Trapezoid method of finding a Riemann sum. So if you have a curve here, draw a little curve here. You have this side, let me do this better. Curve here. You have this side here, you have this side here. Again, your left side, your right side. Instead of drawing a straight rectangle, you're going to connect these 2 points with a trapezoid. And you make yourself a little trapezoid area. Here's your little trapezoid height. Connect both edges, and you've got this trapezoid. It's a trapezoid because you have two parallel sides. Here's a this side here is parallel to this side, and two non-parallel sides. These are not parallel, right? Two parallel sides and two non-parallel sides. To find this in the trapezoid rule, the area of a trapezoid, I don't know, separate this with a line or something. You can see these are separate here. The area of a trapezoid is 1/2 times, normally it's base 1 plus base 2, but I'm going to call this height 1 and height 2. These are the two heights, and you add those two heights together and divide by 2. Times the base value, which is your delta x, which is going to be this here. So you're going to find these two heights, which are going to be the two function values, f of f1 and f2, right? F of x here, f of x here. Add those two heights together, divide by 2 or multiply by half, and then multiply by the base. The delta x distance across those two sections. And this is a trapezoid rule. Sometimes it's a little bit closer, right? Rather than missing all this value up here or having too much out, you're only missing a slight amount. And if it's curving a different way, you'll have a sort of, again, extended amount, but a smaller amount. It's a closer approximation. And so we're going to talk about the trapezoid rule and the midpoint rule today. Hopefully we have enough time. When are we out of here? 11:25. Okay, great. I got about half an hour. So let's do an example with these midpoint trapezoid rule using this formula and see if we can find the area under the following curve. Midpoint trapezoid, the trick is you have to have some, well, for midpoint you have to have some middle value. So let's do an example here where we have a table of values. Oh wait, I need to show you one more thing. Well, let's just do an example here. Table of values. Ah, goodness gracious. Make a table of values. Oh, come on now. I need to learn how to draw straight lines. 1, 2, 3, 4, 5. We need one more. 6. 1, 2. Yeah, here we go. So this is x and this is fx. So I need 1, 2, 3, 4, 5, 6. We need 7 values here. We're going to use 7 values. So let's start at 1, and let's go 2, 3, 4, 5, 6, and 7. Easy enough. F of x, this is going to be 2, 5, 7, 9, 4, -2, and -6. So this is our situation. Here's our table. I want to find the midpoint and trapezoid area with n equal to 3. 3 rectangles. So find the midpoint and trapezoid areas, or Riemann sum approximations, with 3 rectangles. So we have a lot more than 3 spaces, right? We have a lot more than 3 spaces, but we're going to use 3 rectangles to go through this, this process here. Find the midpoint and trapezoid area. I'm going to abbreviate trapezoid just because I'm lazy. Trap area with n equals 3 rectangles. So I want to use 3 rectangles in this sort of function here. So we'll do the midpoint first. Midpoint. So what we're going to do at the midpoint, since we want 3 rectangles, we're going to use, we're going to split this up evenly. We're going to have one rectangle be from 1 across to 3. So there's one rectangle. Second rectangle from 3 to 5, and then from 5 to 7. Evenly spaced rectangles. So we know our delta x here is going to be 2. Here it's going to be 2. Here it's going to be 2. Evenly spaced rectangles going across. And the reason we need to have these evenly spaced is because if I want to find a midpoint, I'm not going to use this side or this side. I have to have some middle point to use. If I wanted to have 6 rectangles, if I said, okay, well, if I wanted to have 6 rectangles, 1, 2, 3, 4, 5, 6, and I wanted to use the midpoint rule, there is no way I could find a middle. I don't know what 1.5 is of this function. I don't have a value here. Right? I don't have a value in the middle. So there is no way I could do the midpoint rule with 6 rectangles because I don't have an equation. I can't plug in 1.5 into some f function. It's just a table. It only tells me certain information. I could maybe guess, but we're not allowed to guess in calculus. We're not allowed to just guess. We have to have a value here. We have to be told, because it could be down to -10, it could be up to 70. There's no way to know what's happening in the function here because we don't have any information. We don't have enough information for that. So we can't do a midpoint rule with 6. If we're only given in a table certain information, we only can use that information in our equation. So we're not going to use 6, we're going to use 3 rectangles. That's why we have to use 3, and we use the middle value of this part. Well, really not that part, but the f value. So to do the midpoint rule, the area is going to be, again, it's the sum. This is going to be I equals 1 to 3 of f of x times delta x. My delta x's here are going to be here, delta x. This is going to be 2, 2, and 2. This is an I, by the way. I equals 1 to 3. The sum of these 3 rectangles. And the f of x here is going to be, let me do this in green, this f of x is the middle value of the rectangle. So in my first rectangle, my delta x is 2. My middle value is this 5 here. This is my midpoint. Midpoint. Halfway between the 1 and the 3 is 2. So its first rectangle is 5 times distance of 2. Second, right, I have, again, a distance of delta x of 2 from 3 to 5. My next rectangle goes from 3 to 5, so that's distance of 2. And the middle value between 3 and 5 is 4, so I'm using my 9 as the height of that rectangle. Again, 5 to 7, that's a distance of 2. Height of this rectangle. Where did I get the 2? So this 2 value here, this delta x, is from, because the rectangle is going from 1 to 3. So it's a distance of 2. Right? You can do 3 minus 1 is a distance of 2, but that's a distance of 2 here for the rectangle. Right? The delta x is the x distance between the start of the rectangle and the end, right? So it's a distance of 2. And then the 5 we use the 5 because that's the middle value. Halfway between the 1 and the 3 is the x value of 2. And the x value of 2, if we plug that into this function, we get the value of 5. This is the height of the middle in between the two edges of my rectangle, this value of 5. So that's the height that I use in my formula when I'm multiplying the rectangles, right? Base of 2, height of 5. Same thing in this one. I got a 2 here. In the middle is 9. This last one, my distance is 2. My height is negative, though. What does this mean? Negative height. Negative 2. What does that mean? Negative 2? Can I multiply? Can I have a negative height? I thought height was always positive. What's happening here? Well, let me tell you a little rule about areas under curves. Negative, question mark. What that means, I'm going to do a little aside over here. Right, pull it over here. If you have a graph, say you have a graph like this, and your function goes like this, it's wiggling, and then it goes down below, and then it comes back up, right? Area, when we say area under a curve, when doing integration, when doing integrals, when doing area, when you have area above a graph, above the x-axis, this is positive area. Above the x-axis, the area is positive. Positive above the x-axis. When your area goes below the x-axis, all of this is negative area. Negative below the x-axis. Below x-axis. So we mentioned that the integral is an accumulation of change. You're showing how much the function has grown. You're doing integration, you're finding area. Well, all of this stuff, when the function is positive, when the area is positive, the function is growing, right? If this was a derivative, right, this derivative graph, positive means it's increasing. Positive means the graph is growing. When the function's negative, well, all this area down here, this is area where the graph is falling, where the graph is decreasing. And so to represent a decrease, we have subtraction. Subtract this area from the positive area. So above the x-axis, your graph is growing, you're positive. Below the x-axis, your graph is shrinking. You have negative area. Again, above the x-axis here, you're back to being positive. So when you're finding area of a function, if that function dips below the x-axis, this part of the graph has negative. You treat this value of area as negative, and it shows when you have a negative value in your area, right? -2. It's below the x-axis, so the area value of this is going to be negative. This is going to take away from the amount of area we have accumulated. And if we are negative enough, we could even lose value from the equation, right? If we're only in the negative, or we have more negative than we have positive, the area is going to end up negative. So be aware, positive you're above, negative you're below. And so we have that situation here, right? Where -2, this -2 means the area of this section of the graph is below the x-axis. It's going to be negative. And so we calculate this out. We're going to get 5 times 2 is 10, plus 18, minus 4, and that's going to be 24. Right, so negative area under the curve. Again, if you want to imagine this graph, we could look at the graph of this. Go this way. One, 2, 3, 4, 5, 6. So again, 1 is 2, 2 is 2, 3, 4, 5, 3 is 7, 4 is 9, 5 is 4, 6 is -2, 7 is -6. So we're finding the areas of this, should go like this, of this rectangle here. That's one rectangle from 1 to 3. 3 to 5 is another rectangle, and 5 to 7 is another rectangle. So if you imagine the graph looks something like this, right? Maybe the curve is going up like this and then coming back down, something like that. Curve looking like that. To find the area of this, we use the midpoint. So this time, instead of using the left side or right side, I use this middle point here, and I said, well, I'm going to go a little bit this way and a little bit this way, and that's going to be my rectangle. This is going to be the height of my rectangle. The midpoint here. And same thing here. Instead of the left or right edge, I'm going to use this middle value here as the height of my rectangle for this one. And same thing here, I'm going to use the middle value. And see here now, you see this area is below the curve down here that's negative. This area is positive, and this area is positive. So we gained 10 here, we gained 18 here, we lost 4 here, and so the total area of this function from 1 to 7 is 24. Questions about that? Again, negative is below the x-axis. See, here's the graph. All right, we're going to try this again. This time, we're going to use the trapezoid rule. Same function, same chart. We're going to find the area of this using the trapezoid rule, however, instead of the midpoint rule. So let's do this one more time. Oh, goodness gracious. Hold on, everybody. What's happening here? Here we go. So the trapezoid rule, the area for the trapezoid is the sum from I equals 1 to 3 again of, this time it's 1/2 f of x1 plus f of x2 times delta x. For the trapezoid rule, we have to use our trapezoid function, right? The equation for finding the area of a trapezoid. 1/2 of the two heights added together, right? The first and the second height. That's a 1 and a 2, by the way. 1 and a 2. The sum of the two heights times delta x, and then divided by 2. So this is our trapezoid area here. Trapezoid area. Area of a trapezoid. That function there, this equation, represents the area of a trapezoid. So we're going to look at our values here and plug these in. For the trapezoid, let's do this in blue, the delta x's are the same. Right? We're still doing 3 sections from 1 to 3, 3 to 5, 5 to 7. 3. We could do 6 for the trapezoid because we don't need to worry about a middle value. For the trapezoid, there's no middle value. It's just the edges. But we're going to stick with 3. That's fine. Compare it to this 24 here. 1 to 3, 3 to 5, 5 to 7. So the delta x is still 2 for each of these sections. For the area, we're going to get, let's see, still times 2, but my heights, 1/2 of, I'm going to have to add the 2, this is going to be blue. I'm going to have to add the 2 heights together, meaning my first edge and my second edge, add these 2 together. This is for the trapezoid. The 2 and the 7. 2 plus 7. 1/2, and it's multiply that by 1/2. 1/2 of 2 plus 7 times the 2. Plus, same thing, my delta x is still 2. And I need 1/2. For my next rectangle, it's going to be the 7 and the 4. 7 and the 4. 1/2 of the 2 edges, 7 plus 4. Plus 1/2 of my edges, this is a 4 and a -6. Okay, so my trapezoid has one positive side and one negative side. 4 plus -6. Is that okay? Well, that's just how it's going to be. One side's a 4, one side's a -6. Overall, it's going to balance out where I have, the area of this trapezoid averaging out to be a number. Times 2, again, the width. So, calculating this, 2 plus 7 is 9. 9 times 2 is 18. 18 divided by 2, this is going to be 9 here. 2 plus 7 is 9. 9 times 2 is 18. 18 divided by 2, or 1/2 of 18, is going to be back to 9. Really, the 2, this 2 here, and the 1/2 really cancel out. There's another way you can look at it. And that happens a lot. So that's 9. This is going to be, again, this 2 and 1/2 cancel out. 7 plus 4 is 11. Plus 4 plus -6 is -2. So I'm going to have a -2 there. And then again, my 2 and the 1/2 cancel out. But I could have, this is going to be -2 times 2 is -4. -4 divided by 2 back to -2. But so 11 plus 9 is going to be 20 minus 2 is going to be 18. So you see, way different than the one I got before. So the trapezoid rule connected these two edges together and made a little trapezoid there, made a little trapezoid there, missing a lot of the upper part up here, but that's okay. And then this trapezoid down here went very negative. And so we had more negative on the side than positive on the side. And so we ended up with -2. Questions about that trapezoid rule? Again, you're using the values from the table. The trapezoid uses the left and right side, adds them together, and divides it by 2. Makes little trapezoids, makes little trapezoid shapes out of your function. And again, if we used 6 chunks for this, you could do 6 chunks with the trapezoid rule. You cannot do 6 with the midpoint rule because you need a middle value. You have no midpoint value. People okay with this? Again, positive is above the x-axis, negative below the x-axis. And you can do this with things that are not tables. Let's try this. Again, we have about 5 minutes, but I'm going to go through quickly one time with a function, how you do this with an f of x equation. Let's zoom back in here. Let's go another example. Find the area, the trapezoid area, just the area of, let's say, y equals 6 over x plus 1 on, let's say, 0 to 6 with n equal 3. So 3 rectangles. Our edges are from 0 to 6. Our boundaries from 0 to 6. So if we want to do the midpoint rule, let's just think about if you want to make a table of values, it might be helpful to make a table. X and y. 0, 1, 2, 3, 4, 5, and 6. If you'd like to make a table that's helpful for you. But what we're doing is we're slicing this into 3 rectangles from 0 to 6. That means we need to cut it into even rectangles. So I'm going to go from 0 to 2 is one rectangle, 2 to 4, and then 4 to 6. Those are my rectangles. Right, the delta x value is going to be from 0 to 6, cut into 3 pieces. Each of these are going to be my delta x's. Each of these are going to be 2. Slicing it into even slices between 0 to 6. And now for the edges, I just need to plug in all these values into my function. Plug these in, get your table, and get your values. Of 0, right, well, that's going to be 6. going to be a 6 here. F of 1, that's going to be a 3. 2 is going to be a 2. 3 is going to be 6 over 4, which is going to be 3 over 2. 4 is going to be 6 over 5. 5 is going to be a 1. 6 is going to be a 6 over 7. And now all of these are my F values. And I use these the same way I did in the other table. So we plug these in. Plug in to find X. Plug in X to find these values here. And you find the midpoint and you find the trapezoidal rule, same way we did it over here, where you have the different x values, use them in the function for the trapezoid, use the middle value for the midpoint rule. Fractions are okay. Just sometimes you got to deal with fractions, everybody. Sometimes. 2 plus 6 over 5, oh goodness. So, what I would like you to do, I give you a handout I'd like you to try. It's not going to be due until Friday, but you can get it started today, where you use the midpoint and the trapezoid rule, as well as the left and right rules, to find some Riemann sums. So let me show you that on Schoology, and then we'll finish.